Hello everyone, welcome to the Equation Web. Today we'll be doing a substitution problem, so let's start with the question. So today's question will focus heavily on trigonometric substitution, so we will substitute in a variable for a trigonometric function. So here is today's question. Find all real numbers x, y, and z that satisfy the following system of equations. 2x plus x squared y is equal to y. 2y plus y squared z is equal to z, and 2z plus z squared x is equal to x. I'll give you guys some time to try and solve this question. Okay, so first we will move all the y terms to one side and all the x terms to the other side. So then we can factor out a y from the left side, and we can divide both sides by 1 minus x squared to get that y is equal to 2x over 1 minus x squared. One way to prove that 1 minus x squared is not equal to 0 is to say that x squared is equal to 1. Then we can plug that into our equation and get that y times 0 is equal to 2x, meaning that x is equal to 0, which is a contradiction, which means that 1 minus x squared is not equal to 0. Using the same logic, we can get all three variables. So y is equal to 2x over 1 minus x squared, z is equal to 2y over 1 minus y squared, and x is equal to 2z over 1 minus z squared. Now we see that every single one of those variables is in the form 2t over 1 minus t squared, where t can be any of those variables. And that is really similar to the formula for tan of 2 theta, which is 2 tan theta over 1 minus tan squared theta. So we can say that x is equal to tan alpha, and alpha is in between negative pi over 2 and pi over 2. So for the first equation, we can plug in that x is equal to tan alpha, and we get that y is equal to tan of 2 alpha. Next, we can plug in y is equal to tan 2 alpha into the z equation to get that z is equal to tan of 4 alpha. And then we can plug it back into the equation for x, which says that x is equal to tan of 8 alpha. Now before, we said that x is equal to tan alpha, and now we got that x is equal to tan of 8 alpha, which means that tan of 8 alpha is equal to tan of alpha. Now we know that the tangent graph has a period of pi. So we know that in order for two tangent values to be equal, they must have an angle that is an integer multiple of pi away from each other. So we can say that 8 alpha is equal to alpha plus some integer k times pi. Now we simplify this equation and we get that alpha is equal to k pi over 7. Now before, we said that alpha is in between negative pi over 2 and positive pi over 2. And now we know that alpha is equal to k pi over 7. So we can simplify this inequality, which is negative pi over 2 is less than k pi over 7 is less than pi over 2. Once we simplify this, we get that k is in between negative 7 over 2 and 7 over 2. And we know that k is an integer, and the integers in between negative 7 over 2 and 7 over 2 are negative 3, negative 2, negative 1, 0, 1, 2, and 3. So we can plug in k is equal to 0, 1, 2, and 3 first into our equations, and we get that x, y, and z are equal to 0, 0, 0 for k is equal to 0. For k is equal to 1, x, y, and z are equal to tan pi over 7, tan 2 pi over 7, and tan 4 pi over 7, respectively. Then for k is equal to 2, we get that x, y, and z are equal to tan 2 pi over 7, tan 4 pi over 7, and tan 8 pi over 7, or tan pi over 7, respectively. Then for k is equal to 3, we get that x, y, and z are equal to tan 3 pi over 7, tan 6 pi over 7, and tan 12 pi over 7, or negative tan 2 pi over 7, respectively. Now we can use the fact that tangent is an odd function, meaning that tan of negative theta is equal to negative tan theta, to find the values for negative 3, negative 2, and negative 1 is equal to k. So if we plug those in, we will just get the negative values of what we saw previously. So the question we just solved was, find all real numbers x, y, and z that satisfy the following system of equations. 2x plus x squared y is equal to y. 2y plus y squared z is equal to z, and 2z plus z squared x is equal to x. Thank you for watching, and make sure to like and subscribe.